by polynomials. This is actually going to take and it's going to require stuff we have learned for the past 2 to 3 note sheets. So we're going to take a lot of ideas and combine them together on this note sheet today. So let's go ahead and take a look at that. So let's quickly review those rules of exponents. Okay, so when you are multiplying like bases, you need to add the exponents. So if you remember what that looked like when we had a to the 6th times a to the 6th, we made that a to the 12th. Okay, we added the exponents. When you're taking a power of a power, if I have a to the 6th and I'm raising that to the second power, we multiply the exponents, so that's a to the 12th. And anything to the 0 exponent is always 1. No matter what you put in there, it's always 1. So those are the rules of exponents we're going to need to use today, as well as what you did on the last note sheet with adding and subtracting polynomials. So let's take a look at this. Do you remember how to distribute? Let's talk about that. So when you distribute, what we did is that 2 is sitting on the outside. So we took and we multiplied 2 into each of those terms. So we took 2 times x, which is 2x, 2 times negative 4, which is negative 8. Okay, same thing with number 2. Negative 3 times x squared is negative 3x squared. Negative 3 times 1 is going to give me a positive 3. So we're going to work with that distributive property today. So let's go ahead and write that distributive property down. Okay, it lets you multiply a sum by multiplying each term separately and then adding the products. So it sounds really confusing, but all that is what we did in numbers 1 and numbers 2. So now we're going to start multiplying in a monomial, not just a number. There might be x's or other letters involved. So to do that, what you're going to start by doing is distribute the monomial to each term in the polynomial. And then you're going to multiply each pair of monomials. Okay, remember when you're multiplying, you're going to multiply the coefficients and add the exponents. So we'll take a look what that looks like in a second. Then you're going to combine any like terms. And last but not least, you need to make sure your answer is in standard form, meaning make sure your exponents are going in descending order. So let's take a look at that. So to start off with, we're going to take x and we're going to distribute that in. So we're going to take x times x, and then we're going to take negative 4 times x. So let's go ahead and simplify that out. X times x is x squared, and there's nothing we can do to simplify my negative 4x anymore. Check to make sure your answer is in standard form. Exponents are going in descending order, so we're good. That one's done. Let's take a look at number 4. So we're going to take this and distribute it in. So we're going to do negative 2x times x, and then negative 2x times 3. So I'm just writing the actual multiplication out because sometimes it's hard to do that in your head. So this negative 2 is going to stay the same, and then we have x times x, which is going to give us x squared. And then negative 2 times 3 is negative 6, and then we have x. So we want to check and make sure our answer is in standard form. Our exponents are going in descending order, so we're good for that one. All right, let's take a look at number 5. So for number 5, we're taking 3x and multiplying it by each of those terms. So I'm taking 3x times 4x plus 3x times negative 1. So I'm taking each term in there and multiplying it by what's on the outside. So 3 times 4 is 12. X to the first times x to the first is x squared. 3 times negative 1 is negative 3, and then we have x. So we want to check that our answers are going in descending order of exponents, and they are. So this right here is your final answer. Moving forward to number 6, we're going to take that 2x and distribute it in. So I have 2x times x squared, and then I have 2x times 7. Well, this 2 is going to stay there. X to the first times x squared. Add those exponents. 1 times 2 is 3. So this is going to become x cubed. 2 times 7 is 14. And then that x is going to stay the same. So this right here is our final answer. We have 2x cubed plus 14x. Taking a look at number 7. So we're going to take that x squared and multiply it to each of those. So I have x squared times x to the first. Remember, if there's no exponent written, the exponent is 1. Plus x squared times, now I want to make sure I take this negative sign with, that minus sign, so it's going to be times negative 11. Well, x squared times x to the first, add those exponents and you get x cubed. And then negative 11 times x squared is negative 11x squared. Your coefficient always comes before the variable. So we have x cubed minus 11x squared. All right, next, let's take a look at this one. So we're going to take that 5x and distribute it in. So I have 5x times x squared plus 5x times 4x plus 5x times a negative 2. So if ever it's a minus sign, you want to make sure you take that minus sign in when you're multiplying them out. So we have 5 is going to stay the same. This is the same as x to the first. X to the first times x squared, add those exponents and you get x cubed. 5 times 4 is 20. And then we have x to the first times x to the first, add those exponents and we get x squared. 5 times negative 2 is negative 10, and again, keep that x the same. So check to make sure your exponents are going in descending order, which they are. So this is your final answer then in standard form. Moving forward, let's take a look at this one. So we're going to take and we're going to distribute in this negative 6. So it's going to change the signs of everything. So the first one, we're going to have negative 6x times x cubed, negative 6x times negative 3x, again taking that sign with, then negative 6x times 1. So let's go ahead and calculate each of these out. Negative 6 times 1, that's going to be negative 6. X to the first times x cubed is x to the fourth. Negative 6 times negative 3 is going to give us plus 18. X to the first times x to the first is going to give us x squared. Then negative 6 times 1 is negative 6, and then we'll take that x along with it. So this is our final answer. So you want to make sure every time you multiply each part out that you have a plus or a minus sign that separates each of them. Okay, so that's your final answer for that one. Let's take a look. Whoa, whoopsies. Let's take a look at number 10. Okay, so for number 10, what we want to do is first, we're going to take that 2x squared and distribute it in to each term. So we have 2x squared, and that's going to be times x squared. Plus, we're going to add the terms 2x squared times, and then that's going to be a negative 3x when you take the sign with, plus 2x squared times 8. So I'm taking each of those terms and multiplying them by 2x squared. Well, this is going to stay 2 because this is the same as 1x squared. X squared times x squared, you're going to add those exponents and you get x to the fourth. Next, we have 2 times negative 3, which is negative 6. X squared times x to the first is x cubed. 2 times 8 is 16, and then you get x squared. So this right here is your final answer. I have 2x to the fourth minus 6x cubed plus 16x squared. So all of my like terms are combined. I can't add any more. And then all of my exponents are going in descending order. All right, let's take a look at number 11. So we're going to take that negative 3x squared and distribute it in. So I have negative 3x squared times a negative x squared. And then I'll just do a plus to remind myself that it's a different term now. Negative 3x cubed times a negative x squared. Oops, sorry, a negative 5x. And then a negative 3x cubed times 4. So now we want to take and we want to multiply each of these terms together. So negative 3 times negative 1 is a positive 3. X squared times x squared is x to the fourth. Moving on to our next term, negative 3 times negative 5 is negative 15. Or sorry, positive 15. When you add two negatives, it's positive, you silly Miss Humbert. X cubed times x to the first is x to the fourth. Oops, this should be x to the third here. So this should be x to the fifth. Hopefully you guys caught that. Okay, so the mistake I made is that this guy right here is supposed to be x to the third, so this should be x to the fifth right there. Last but not least, for our last term, negative 3 times 4 is a negative 12, and then we'll keep the x cubed the same. So right now I have 3x to the fifth plus 5x to the fourth minus 12x cubed. None of those can be combined together because they don't have the same exponents. So that's your final answer in standard form. All right, let's take a look at number 12. So for number 12, we're going to take this 5x to the fourth and distribute it in. So I have 5x to the fourth times 3x squared. Now moving on to the next term, 5x to the fourth times a negative 2. So 5 times 3 is 15. X to the fourth times x squared is x to the sixth. 5 times a negative 2 is a negative 10, and then we have x to the 4th. So our exponents are going in descending order, and all of our like terms are combined. So this right here is our final answer. So let's take a look at this word problem. It says the area of a rectangle can be found with the formula area equals length times width. The length of a rectangle, so let's draw out my rectangle. The length of a rectangle is 5x. And the width is x squared minus 3. What is the area? So the area is length times width. So to calculate this out, we're going to take 5x times x squared minus 3, and that's going to give us the area. So now I want to take this 5x and distribute it in. So remember that this is x to the first. So we have 5x times x squared plus 5x times a negative 3 when you distribute it into each part. So then 5 times 1 is 5. X to the first times x squared is going to be x cubed when you add those exponents. 5 times a negative 3 is a negative 15, and then you have x. So this right there is your final answer. So that concludes your note video today. Go ahead and show me your completed note sheet when you're done. It's a little bit of a shorter video, so remember if you have extra time at the end, you want to get working on some missing work. Thanks for listening.